Okay, so I have a set of data here, and what I want to do is I want to make a box plot, a box and whisker plot, and also look for any outliers in the data. So what I'm going to do first is I'm going to find my quartiles. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 values here. So my median is going to be the 8th digit. 1, 2, 3, 4, 5, 6, 7, 8. Now, why the 8th digit as my median? Well, if there are 15 numbers, the 8th digit has 7 to the left and 1, 2, 3, 4, 5, 6, 7 to the right. So now that there are 7 and 7, I need to look at the medians of these other halves. And I'm going to call them quartiles. So if I look at the median for these bottom 7 numbers, they will be the 4th digit because, again, this has 3 to the left and 3 to the right. This is Q1, or the median of this lower half. Then I'm going to be looking at Q3, which is going to be the median of this upper half. And of course, median is quartile 4. So now what I want to do is I want to make my box and whisker plot. Actually, I'll tell you what I'll do. We'll find the outliers first, since that's the key piece here. So outliers. So what we want to do is we want to have first off find the range, the interquartile range. Interquartile range is Q3 minus Q1. So in this case, that's going to equal 14.9 minus 14.4. That's very, very small. So that's going to give us 0.5. So if I want to find outliers, it's going to be greater than Q3 plus 1.5 times the interquartile range. Well, if I do 0.5, which is the interquartile range, times 1.5, that's going to give me 0.75. So if I have Q3, which is 14.9, and I add that 0.75, I'm going to get that I'm going to have outliers that are greater than 15.65. So looking here, do I have any values that are greater than 15.65? I actually do. I have 2. So these 2 are outliers. Now I'm going to also look at values that are less than Q1 minus 1.5 times the interquartile range. So Q1 is 14.4. And again, the interquartile range is the same. It's that 1.5 times the interquartile range. It's 1.5 times the interquartile range of 0.5, which is going to give me 0.75. So if I do 14.4 minus 0.75, I'm going to have outliers that are going to be less than 13.65. Do I have any values less than 13.65? I do. I have 1. So this is also an outlier. Why don't we make a box and whisker plot of this just to emphasize this point home? Right. Now, I actually have a relatively small range from maximum to minimum. So the range here is about 6. So I'm going to break these up into halves. And so I'm going to say that this is going to be 10. This will represent 10.5. And this will represent 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15, 15.5, 16, 16.5, 17. When you're making a scale, it's really whatever you feel like. There is no set way to make a scale. I mean, obviously here, if I made my scale of 10, it wouldn't be very effective because I'd have to estimate for all these values as I would go from 10 to 20. It would not be effective. So here I made it 0.5 and I labeled the ones. So my smallest value is going to be 10.2, so really close to 10. Maybe about there. The largest value is 16.4, so if that's 16.5, 16.4 would be about there. And then again, I'm going to have those vertical lines to represent my quartiles. So 14.4 for Q1, 14.6 for the median, and then 14.9 for Q3. Now if I make this into a nice little box here, or do my best to make this into a box, you can actually see just how far apart these extremes are. So here, those whiskers, those are some long whiskers. Oops. I'm actually going to move this point up just so it looks a little bit nicer. And again, you can see just how far apart these are. So that's why this value down here is actually an outlier. And these two up here are outliers. Because if I look at this interquartile range, this represents 50% of my data. So if I go 1.5 times beyond that, this is really far out there. There's not a lot of data out there. Same with this. This is just skewing my data. So that's why these are outliers. Now sometimes you will see box plots constructed where they go to the lowest value that is not an outlier. For our purposes, we're going to include all the data and we're just going to label the outliers and say that 10.2, 15.9, and 16.4 are outliers. So again, what we have to do is we have to find the interquartile range, find 1.5 times that, and then anything greater than that value, so in this case greater than 15.65, and anything less than 13.65 is going to be an outlier.